All right. So up next, we have Ger, who's going to talk about manageable Puppet infrastructure. And then he can repronounce his name in the proper way, since I didn't get it quite right.
Test. Okay. Guten Tag. Mein Deutsch is ganz verrückt, so I'll switch to English immediately. I'm here to talk about manageable Puppet infrastructure. I'll introduce myself first. My name is Ger Apeldoorn. I'm from the Netherlands. I am a freelance Puppet consultant, and I also do the trainings for the Netherlands as well. I decided to create this talk because there are a lot of talks and websites on how to implement a specific component in the Puppet infrastructure. And there's not a lot on how to set up everything and get a working infrastructure that's actually manageable and where people can collaborate on it. When I was working on it, I also found out why there isn't one, because it's pretty hard to put all of that in a reasonable time frame. So I have to talk fast, I guess. So when you're starting out with Puppet and you're implementing it for your company, there are a few design decisions that you have to make right up front, but you don't have the technical background yet to actually make good decisions. So you probably end up with quite a few workarounds, and a lot of workarounds will result in an unmaintainable code base. And usually people don't think really hard about how to facilitate collaboration, not only between direct colleagues, but also if another department wants to contribute code, stuff like that. So there are a few quick wins. You can move all your data to Hira to separate the data from the code, which is really helpful. Also, you can implement code review, and that's not as much about preventing mistakes to enter your production environment, but because you probably test it, I hope so, beforehand. It's more about making sure that everybody takes a look at each other's code. So if my colleague runs into a problem and uses a certain way to fix it, and I run into the same problem a week later, I'll probably use the same method. So the ways of programming tend to align on that. So also, if I'm hit by a bus, my colleague still understands my module, so they can fix it. Of course, all your code should adhere to the style guide, and there's an automated way to test for that with Puppet lint. And if you put that in a Git hook, so that you can only commit code that adheres to the style guide, that's pretty annoying in short run, because you'll have to refactor a lot. But on the long run, it's really helpful. So, okay. This design kind of evolved over a lot of consulting jobs, and I found that it's very useful in most companies. So, of course, this is my opinion on what's useful, so you might not agree with me. We'll look at that later on. So, what do we need in a good environment? Our environment should be easy to use. It should be easy to comprehend, of course. Easy to update, and of course safe to use. But unfortunately, it isn't exactly easy. I'm using some extra tools here that each have their learning curve, and you have to get to know them. But if you do use them, it's really helpful, because your code can be a lot simpler and easy to use if you take that extra effort in learning these tools. Of course, we can make it safe and manageable. So on the safety part, you want to use environments or separate Puppet masters to make sure to test everything before it hits production. You never ever want to edit your code in production. And I always try to create a very big testing environment. So I don't mind if I break something if in testing that there are a few developers that are angry at me, because if you break something and nobody finds out because there are two servers in your testing environment, you can't be really confident promoting your code to the critical stuff which should be in production. So, and I like to use Git to promote all of my code. So on the manageable bit, you want to go really OCD on the consistent module structure. There should be, if you're looking for where something is managed or where a piece of data should be, there should be one really good place to put it. And that saves you a lot on finding stuff, which is annoying, of course. I like to use roles for abstractions as well. Later on, Craig Dunn will be here in his roles and profiles. This is kind of a bit simpler on that, but Craig will probably prove me wrong on that this afternoon. And also, it's important to facilitate collaboration. So not only to direct colleagues, but there might be a provisioning department that wants to contribute code, and you should be able to facilitate that as well. So, I'm talking about a few things here. Server roles, stuff with Hira, data. You can do quite a bit with that. And I'll have a live demo with a workflow of deploying stuff. And also we'll take a look at some Hira data and wrapper classes. So, a few software components. So this setup works with Puppet Enterprise, but also the open source, for instance, Forman. I'm using Hira a lot, but not the default backend. I use Hira YAML, and this is pretty much the same as the YAML backend, only you can encrypt individual values, which is quite important because my Hira data is also in a Git repository, and I don't want any database passwords there. For code review, I use Gerrit, which also acts as a Git repository, and there's a workflow, Git flow, which pretty much describes how to get your code from when you create a new feature to all the way to releasing it. And I use that because Git is a very flexible tool, so it's pretty much impossible to make everybody use it in the same manner. And by using Git Flow, which is an extension, you get some extra tools, a Git subcommand, and this will help all the developers of Puppet code use the same methodology to promote the code. And lastly, I use R10K, which can be loosely described as an environment deployment tool. We'll look at that later on as well. So, first a bit on roles. I never include a module that actually does anything directly to a node. I like to put a level of layer of abstraction there. So, for instance, I have a role lamp, which is a class, and that one includes Apache and MySQL. So later on, when I want to make a change on all of my LAMP servers, there's one place to do that, and I don't have to go through all of my other node definitions. And that's really convenient. So how do we do that? You can just create a new module, and I always create a base class. So in this case, there's a role base where I include stuff that is applicable to all of my machines. And then for each role that you want to define, you create another class in the role module where you can include other modules, but you can also put resources there if you want to. And of course, you have to include those classes. And this is one way to do that. There's actually a smarter way to do. I always use Hira for this, but we'll look at that later on. Get a quick drink. Okay. On to Hira. You pretty much, everybody has heard of Hira, I think. Who is not using it yet for the code? Okay, quite a few people. Okay, you're gonna love this, I think. Of course, Hira is all about the hierarchy. You define a hierarchy in the hira.yaml. It's pretty simple. In this case, in the examples, the top level is client cert, which translates to the fully qualified domain name. You never want to use the FQDN fact here, because I found out the hard way that it's not very reliable. For instance, if you have a search path with a different domain there, it just uses that one, and that kind of sucks. So client cert is set when you generate a certificate, so that one never change. Also, you cannot override it. The FQDN fact you can override, but this one you can't. So that's pretty good. So that's the top level. The second level is in which environment the Puppet run is done, and the third one is common, which isn't a variable. So that one, that's taken literally. So if we have the call right at the bottom, we look up Hira and example key, and let's say that we're on a machine called app01 in the environment testing. It will hit at the first, at the top level. So we have a client cert that will it will look into this YAML file and find the value for example key there. If we were compiling a catalog that was for a different machine, let's say the app02, that didn't have the example key in its Hira file, it would fall back to the second level, if it is in the testing environment, of course. And then example key would be, the value would be value for nodes in testing environment. So, and that's a bit on the hierarchy. You can put different types of data in a YAML file. You can have regular values in there, or you can put arrays in there. There are two ways to describe them. It's on a single line or in multiple lines. The indentation is important, and you got to make sure that you always use spaces for that. If you're using a tab, you will get an error message that doesn't point you in the right direction at all. So yeah, that's kind of a nasty one. Also, you can put in hashes, key value pairs, or you can just combine them all and make as much of a mess as you want. So, a few functions that are using Hira. We've seen this one, just the Hira function. You look up the key. You can provide a default value if you want. So if it cannot find it in Hira, instead of giving an error message, you will get a default value. So you can use it for a variable lookup, and this really prevents if statements in your code. You know, it's really good to handle exceptions in this way. So in this example, most of my machine will get the data from the common.yaml file, my main mail server. I don't want to look at the mails from testing, so I'll point them to a dummy test SMTP. And my own mail server, which is my smart host. It shouldn't send its mail to itself, of course. So that one gets the value of the smart host for my provider. So no more if statements in my code. Next up is the Hira array function, and there's also a Hira hash. Although you can collect arrays and hashes with the regular Hira function, this one does something special. The regular Hira function stops at the first hit. This one just continues through all the levels, and it will concatenate all the results. So in this case, if I'm still on the app01 in the testing environment, this call at the bottom, it will result in an array with 5 elements. If I would do this on the test02 that doesn't have the user's key, it will result in an array with 3 users. So that's really flexible in that way. And there's also Hira hash, which does pretty much the same thing, only with hashes. So With Hira include, we can load up an array from Hira, and it will include all of the elements from that. So I use that for roles. In my node default, I don't have to specify all of my nodes anymore in the site.pp. I just use node default and do Hira include roles. And it will look up the key roles. Also, it goes through all the levels, so it will concatenate the found values. So in this case, the web01 will get the role web and the role base class assigned to the machine. So, and you're using it kind of like a lightweight ENC. Good. This is probably my favorite, create resources function. This can, create resources, pretty obvious. They can be of any type, so you can create users, files, packages, but also define types, like in this example, the Apache vhost. You can use create resources to make them. And it takes the first parameter is the type that you want to create. And the second one is a hash. And of course, we can just load that hash from Hira, and that makes it a lot easier. As you can see here at the example, create resources, Apache vhost, so that's the type we're going to create. And I put in a Hira call that looks up vhost, and it has a default of an empty hash. In this way, if it cannot find a vhost key in Hira, it will just do nothing and won't give you a nasty error message. So with this one line, I'm creating 4 vhosts. And so that's the first level is, we've got 4 here. So 4 vhosts will be created. At the second level, those are parameters of this defined type. So the first one will have an alias, and for instance, the last one will have the port parameter set and the doc root. So that's really a flexible way to do this, to solve this problem. Okay, starting with Puppet 3, we have data bindings, and what Puppet does is it looks up the variables of classes that you're including. So for instance, if I include MySQL Server, it has a few parameters, and it will automatically load them from Hira. And you can still make use of the hierarchy levels. So for instance, in this example, it has 3 parameters, but for one server, I want to make an extra secret password. So most of my machines will have the root password top secret, and my one machine will have it more secret. So that's really an elegant way to put your class parameters there. So if we put everything together, then pretty much everything that's node specific you can load from Hira. So the Puppet run will have, if you do a Puppet run, of course we leave the ENC out of this picture. It will first look in site.pp, where it finds a node default in a Hira include, looks up the key roles from Hira, and it will load the class role app. So that will be included. So in my module path, there is a module role, and in manifest there will be an app.pp, which has include Tomcat in there. And as you can see, the init.pp of the class Tomcat accepts a few parameters, and it will load them from Hira. It will look under the key, the class name, and colon, and the parameter name. So Tomcat class will look in Tomcat colon, Java home, and it will load its value from Hira. So on the deployment and workflow part, first a little something about environments. An environment is pretty much a separate module path and a site.pp. So you can have your modules for the development environment in a different directory than the ones in production. And you can, you mostly see development, testing, production. They all are checkouts from the same Git repository, only the versions vary. So development is more likely to be newer than testing, and testing newer than production. In the configuration of the nodes, you can set an environment, so a node can request a specific environment. With Puppet 3, if you set it, you can also set it at the ENC level, and if it's provided there, that one always overrides the setting for nodes. So these environments are essential to prevent mistakes. Of course, you can also create different puppet masters for each, for development and one for testing and one for production. Usually I find that to be a bit overkill. You can manage with environments very good. So basic line is you never ever want to edit your code in production. So, and the workflow with Git Flow, that's helpful to promote your code. So when you've developed something, to make it end up in production eventually. So, I've got a Gerrit server here, and I've got a few projects. So I go to the list. Of course, there's a Hira Git repository where all the data for Hira is there. If you really want to keep it in a separate repository, because yeah, Hira data tends to most of the changes that you do in Hira apply to one single host, and you really want to be able to deploy that quickly. So I've got a Puppet repository here with R10K. Every module is in a separate Git repository or downloaded from the Forge, so there's no big thing here. And R10K uses this main Puppet repository to deploy environments. So more on that later on. I always create a company-specific module to put very specific, that's not reusable for other companies there. And of course, I have a role module. So, let's see. It's visible. So this is a checkout of my main Git repository. There is a modules directory here, but it's not part of Git, because I've got it in Git ignore. There are a few files that are important here. PP, which sets a few default setting for a firewall, and there's a node default that does a Hira include of roles. So that's pretty simple. More interesting is the Puppet file, which is a list of modules that I want to use. It downloads them from the Puppet Forge, or you can, but you can also use local Git repositories or one from GitHub as well. And what R10K does is you have a main Git repository, and for every branch that it finds there, it can create a directory in the environment directory that you specify. It will take the corresponding Puppet file that it finds in that specific branch, and it will download all the modules for you. So, for instance, if we have, in this example, we have development, testing, production, and also one release branch there. It will create all those in the environments directory and download all the modules. So if we look at a tree from the etc Puppet environments, you see that there's a develop environment there, master that isn't used, production and testing, and each of them have quite a few modules in there. And this should correspond with the branches that I have in my Git repository. So, on Git flow, we have a subcommand, and for instance, I want to develop something, so I create a feature branch. Feature start. So I create a feature named Berlin, and now I can make some changes to the Puppet file. For instance, I want to clean up this mess and delete a lot of modules. So this is now in my local machine. Let's see if I do a git status. There's a modified Puppet file there. So I committed to my local Git repository, and I can do several things now. I can I can publish this branch to the central repository, and R10K will create an environment for me that uses that. With the current internet connection, I'm not going to demo that. But let's say that I'm happy with the results. I've tested it somewhat, and now I want to have my colleague look at it. I can do a git flow feature submit. Accept the message. And now it's submitted to Forman. So I can tell my colleague, well, I've got something that you can review. It's in Forman. So he can click on it. And there's some generic information here. And you can look at it side by side, what are the changes. You can also use this command to download a copy of its own, to fetch it and to test it against a real machine. And if he's happy with it, he can click review and give it points. So if he's pretty sure that it's going to work, he gives it 2 points. Every change needs 2 points to be able to be merged in the main repository. So if he's not quite sure, it looks good, but someone else needs to give it another point. So if I click publish and submit, then it will be merged back into the develop branch. If it was not accepted, if it was denied, then I would go back to my feature branch, make some additional changes, and resubmit it. So it can be an iterative process. So if I'm happy with it, I finish this feature. So sync it up again. Oh, wrong order. So, and I'm back at my develop branch. So my changes has been committed back. If I run R10K now, R10K deploy environment -p. So -p is that it has to download the modules as well. It will check out the Git environment. So in my develop branch, it has to clean up a lot of modules. And that shouldn't take this long. Okay. So if I look at my tree now, you see that the develop environment is much shorter. So it cleans up after itself as well. If I would remove an entire branch, it would remove it from here as well. So, of course, because of that behavior, if you want to develop on the Puppet Master yourself with your own environment, you shouldn't put your own environment in that place, because R10K will remove it. So That's why I always create a separate environment to develop in, which is out of the environments path. As you can see here, the in the manifest and module path, there's a variable, so I can dynamically use environments within Puppet. So configuring R10K is quite easy. It's just a YAML file, point it to the Git repository where it should get the main Git repo, and you give it a base there which it can manage, and that's pretty much it. So. Okay, so I've made my change into develop. I can put it, I can do a release doing that. I've changed the Git workflow a little bit because in the normal one, if you do a release, you release it into production, and I'm too chicken for that. So I let it release in testing, and then if nothing breaks, I merge those changes back into production. So if I create a release branch, I have to have a version number. Yeah. Let's see. Oh, we're at 1.0. So now I'm on the branch again. I can make some final changes. I'm not going to do that. I'm just going to copy paste this. So, and now I'm on my testing branch, and I can commit those changes, can push those changes upstream. So git push origin testing. And when I run R10K again, my testing environment will be cleaned up as well. So, small testing environment. So, and with Git Flow, you can also create a feature environment just like that. Git Flow feature publish will create that. So that's pretty easy. Okay, so let's see. So now my production environment is updated as well. Okay, so that's on the workflow. This is my roles module. A role can be quite simple. For instance, the role DB, which just includes a class. But they can get quite complicated as well. For instance, this is one for a Django app server, which has quite a bit of stuff in there. Python needs to be there, some packages, paths, whatever. So you can make it as complicated as you want. One line is nice to see. There's a create resources below that, so that we know if a machine has this role, it should also create resources of the type Multiplan Plan App, which I'll show you later on. And it will load that data from Hira. Okay, so if we take a quick look at Hira, there's a common.yaml here, which loads the role base, some extra stuff. And if I look at a host single, at a machine, you can see I can assign multiple roles to a single machine if I want to. And here you see data for the create resources that we saw earlier, Multiplan Plan App. And there's one value that's encrypted, the DB password. Hira YAML encrypts the values with certificates. So as long as you don't put the certificates in the Git repository, then you're pretty safe with it. The command to decrypt it and edit your code is, you need to specify the path to the keys, and I'm much too lazy for that, so I created an alias, evim, so I can remember it. So if I use this command to decrypt it, you can see the DB password has some extra stuff with it around it, and it's decrypted. If I want to encrypt another value, I can just type some stuff around it. And when I save it, it's encrypted as well. So if I use the regular vim to open it, there should be 2 encrypted passwords there. So that's very nice. So if I look at my hiro.yaml, you see that there's a backend YAML here. And I've created some private keys and a public key. And also I override the extension. So I just wanted to look at regular YAML files. And there's a simple hierarchy there. Okay, so we have a quick look at this module. We're downloading all the modules from the Forge, and you really want to try to keep them as they are, because if you make changes, then it's very hard to update them later on. That's not very desirable. If you want to include a class or a defined types, and you want to add a little extra to it, you can create a wrapper class. And these are quite simple to use. And this will prevent you from having to change the original work. So if I look at manifests, for instance, in this example, I wanted the virtual host from nginx, but I wanted some extra stuff added. I could have changed the original, but I would shoot me in the foot later on. So I created a wrapper class, which accepts all of the parameters that the original one has, including the defaults. You can add a few if you want to later on, like site type. I've added that. But all those parameters, I just pass them on to the original. And after you've done that, you can do some extra stuff like everything with PHP, that it should forward those connections to fastCGI, create a document root, stuff like that. So, but you can also use this, so this is in the company specific module. You can also use this to create your own defined types. That's just a combination of other modules and other classes. So for instance, for this planner application that we've got, I created this defined type, which was used in the create resources statement, and that pulls everything together, creates a user, makes sure that it's started, stuff like that. Create a virtual environment. So all these components you can join up, create your own defined type, and the company-specific module is a great place to do that. Okay, so some final remarks. Try not to touch the original. Use wrapper classes. If something's broken with the original, you can put a fork on GitHub. There's always in the Forge, if there's a project URL. If you click on that, you end up on GitHub, and you can easily fork that project. And of course, it's good if you fix something that's broken, create a pull request for the original author to make sure that your fix gets incorporated. And you can still use that Git repository, your own fork. You can put that in your Puppet file, and so that just works. As always with Puppet, try to think ahead and try to anticipate future applications while you're building. And because it's really hard, yeah, it's really easy to write yourself into a corner, of course. If stuff feels very complicated, not very stable, there's probably an easier way to fix the problem. So try to find out instead of working on it. And don't forget to refactor. If you see an improvement for your Puppet infrastructure, try to make the time to fix it and to make it better. Because if you wait too long with that, sometimes you just have to start all over. So that's not very good. If you take the time to make these little changes over time, that's really helpful. So, any questions? By the way, everything I've shown you, how to set that up, you can find it on my website, also the presentation. So you can look at that later on, which is at that URL. So, any questions? Yes.
You mentioned that we use a YAML file to define the passwords. Are the passwords shown during the Puppet run?
The passwords that they are in the YAML files. The question is if they are shown in the Puppet run. Well, they are in the catalog. So yeah, if you're managing if it's set at a file. And you're using a verbose output, then you'll probably see it. Yeah. Yeah. So, by the way, the certificates that's used to encrypt those YAML files, they only have to be on the server, on the Puppet master. So, because that's the only part that does the querying, you don't have to spread them around to all of your hosts. So, yes. Mm-hmm.
So you change, you take
the remark is that you can also use host groups in Forman, right? Yeah. Yeah. That. You could do that. You would still create the role classes, but yeah, okay, I see where you're going. Yeah, yeah, you can use the Forman to connect the different classes that do the actual work to the machines. That's a personal preference, I think. I don't like to click. I'm a recovering Windows admin, so I really despise to click. Okay. Yes.
Is there any system in place that will provide some form of API documentation for your types and stuff? Because you showed that you can define most anything in Hira.
Mm-hmm.
So is there any information store for the users how they need to structure the Hira data to get what they want to do, or will they always have to look at the module and see what parameters are there?
I'm not aware that there's something centralized to do that. You probably just have to look at the module. Yeah, do you mean the data bindings part, or just in general?
The question, if I define an Apache host, what are the parameters that it has? What do they do?
Yeah, okay, yeah. So the question is, if I want to define something in my Hira data, is where can I find the parameters for the different class, the defined types? You'd probably have to look at the at the definitions. Yeah, yeah. You could, of course, make a dummy Hira file and put them all there, just as examples. So that would be another solution. Yeah. Okay, so I'm out of time. Thanks.